Alright, so 9-point circle is an interesting property of a triangle ABC here, where we have a blue circle here. It has 9 special points. So today we're going to prove the 9-point circle. So here is what is called the DEH, the midpoint here, and we have the feet of the attitude lines. This is the vertical lines, AU. Here is AU, and BV here, as you can see. This is BV here, and the CW here, right? So we have 9 points here marked here. The DEH, the midpoints. UVW, the feet of the attitude lines, and XYZ, the midpoint of this edge is auto center. That is the intersection point of the 3 attitude lines. So if you do AH, midpoint is X, and BH, the midpoint is Y, and the CH midpoint is Z, XYZ, the 3 points are the other 3 of the 9 points. So we need to prove that they're actually on the same circle. How do we do that? So we're going to let's copy that figure here. I'm going to clone it. Okay, so let's look at let's remove the distraction here. So one property, we know that for the 4 points on the same circle, let's say any A, B, and C, and D here, let's get rid of that. I mean to draw a straight line here from A to D and from C to D. Okay, one property is that the angle extended by the same arc AC, and these 2 angles equal to each other. So in other words, if angle B equal angle D, we know that ABCD are in the same circle. In other words, if you don't have the circle here, right? If you see 4 points, they're going to be on the same circle. That's one. Cut this one. If we have AC, so if the bigger angle here, the angle B, the big B here, in other words, the angle ABD equal 180 degrees minus the opposing angle here is going to be ACD, right? ACD. Then the 4 points are on the same circle, determined by the midpoints. All right. So for the proof, so let's erase all this. So for the point, we're going to choose DEF here, right? So we're going to choose D. Okay, so D, F, and of course the circle here is going to be this blue circle, right? So we have DF. Now we first want to prove that the fit of the let's say D, E, F, U are on the same circle. So because of this distraction here, let's make the copy and okay. So this is our new problem, is to prove this part, right? So we need to prove this. All right. So for this purpose, we can remove all these unnecessary lines here, right? And let's cut it for now. We're going to get it back later, right? Here, so we're going to connect with yet a different color here. I'm running out of colors now. Okay. So D is a midpoint. E is also a midpoint. So if I make the connection here, this is going to be parallel line. Okay, so D going to be parallel of AB, right? Because 2 make the connection here, and this is EF is also midline, so it's parallel to BC. Okay, so we want to put in here, and then we will make another connection here, and this one. Okay, so I can remove this direction here. So what we do here, number 1, and equal number 2, then we can know that the 4 points are on the same circle, right? So in other words, we need to prove angle 1 equal angle 2, right? So here, you know, this particular one here is parallelogram, right? So which means this is DF is parallel to AC, and the D is parallel to AB. So which means the angle 1, okay, so the angle 1, from the property that they are midpoint parallelogram, and angle 1 is equal 180 degrees, and then the equal angle A, right? So let's say angle, this is AFD, and that would equal angle BAC. Okay, 2, angle 2 is going to be 180 degree. So for the whole angle here, let's mark it. You know, this is a 180 degree angle, right? Yeah, so let's erase that. And you minus, let's say this is called angle 3. Oh, sorry. Let's say this is called angle 3. This is angle 4, right? So 180 degrees minus angle 3 minus angle 4, right? Alright, the embarrassing, this is actually not the way to go. Let me see. Wrong thought. Okay, sorry about that. Let's erase that here. Let's actually get the attitude line back. Alright, so I'm going to make the connection here. This attitude line here, the vertical line, right? So there's an important property that if we look at alright, so let's review another geometry effects. So if I have a 2 parallel line here, right, and then if I have line cut like that, right, so the ratio here are all equal to each other. In other words, if I have ray A, B, C, D, E, F, G. So if the parallel L1, L2 are parallel, and then AB over BC would equal AD over DE equal AF over FG. Okay, so in this case, let's highlight the line here, right? So we can do highlight. This is parallel line here, EF, right? EF is parallel line, and this one, right? I have two rays here, AB, AU, and AC. So the ratio here is 1. The cut here, this segment is going to equal 9, and is bisector perpendicular, right? So for the, let's say this is 9 segment A and 9 segment, let me see, A and U, right? A and U, A and U. And if you have a perpendicular line bisector here, then every angle here is isosceles triangle, right? So this would equal here. This is not drawn to scale, okay? So they would equal to each other. In other words, in this diagram here, you have perpendicular line. So what happens is this highlight here. I have too many highlights. Okay, let's undo the highlight. All right, so what I'm going to highlight again is for triangle AEU. All right, this is isosceles triangle because this is vertical line here. This is because this is isosceles triangle, so this angle here is going to equal to each other, equal to this, right? And similarly, the other triangle AFU, right, is also isosceles triangle. All right, so it's equal to each other. So which means this angle here would equal this angle. So if the BAC is going to equal the other one is EUF. EUF. This is earlier the angle number 2, right? So this is exactly angle number 2 we marked earlier. Okay, so in other words, 1 and 2 equal to each other. So let's redraw that to make sure we have this marked clearly. So let's remove everything here. Remove this. Remove those. Okay, and these. Let's get the angle back. All right, let's highlight that. So we have shown that this angle here, right, equal this angle here. Okay, 1 and 2 are equal to each other, right? They both equal the angle A. So which means these 4 points EF, D, and U. Somehow it's not responding here. Yeah, they are on the same circle. Now, similarly, you can prove other foot, right? So far we have proven that for the circle goes through these 3 points, and then the foot of the attitude U is also on the same circle. Now the original diagram here. Okay, let's copy paste. All right, so here we have we'll get rid of this circle here. Okay, all right, so we have the blue circle is for the goes through the midpoints, right, which is the DEF. Earlier we have proven that on the same circle the foot, which is UVW, on the same circle. Now we need to prove XYZ. Let's pick a point, right? Let's say X. Here is a midpoint. This is very laggy of A and H. What is H? H is ortho center, right? So in this, let me zoom out. So this is the X here, right? So how do we prove that? So again, we're going to use the fundamental property, right? So in order to prove is a midpoint. So imagine if I make a connection here by the F and the X, right? If we connect the X and this, I'm going to make a dotted line to let it stand out, right? So this one, I claim that is F X is parallel to BV. Why? Let's highlight the triangle here. Let's highlight a triangle with a different color. Let me see, what is this pen? This may be a bigger highlight. Okay, so the triangle B, oh sorry, can I use that? This is too thick. Try this pen here. Okay, the triangle BHA here. So I have a midpoint F and a midpoint X. You make the connection. This is parallel, right? Okay. So that's now, and in order to avoid, I'm going to undo all that. Okay. Here, let's mark the angle BHC. Okay, what is BHC? Again, let's try to highlight here. Is this angle here, right? This angle here. Now, opposing angle here, which is opposing angle, is going to be VHW, right? So VHW, right? So VHW, we claim that is 180 degree minus BAC. So why that is the case? Okay, so let's take a look. I claim that this is 180 degrees minus the big angle A, which is BAC, right? For some reason, this doesn't work very well today. 180 degrees minus angle A, the BAC. Okay, why that is the case? Okay, let's draw another diagram here. Let me explain why that is the case here. I'm going to make it bigger. Let's look at these 4 points here. Okay, I'm going to highlight. Let's look at the, okay, this A, W, V, and H. Okay, so here this is a attitude line, which means this is 90 degrees, and this is also 90 degrees. Okay, so which means they are on the same circle, and so that this add up to 180 degrees. All right, so that's the reason. All right, so let me erase this because we don't need that now. Okay, so make the connection here. Here makes the connection. Use dotted line here. Okay. Oh, wait. Okay. And X and E, right? Okay, make that to be the dotted line here. Oh, wait. Let's see. This is it's very hard to. Okay, now it's selected. Okay, this one. Okay, so all right. So this we get that. Mark that. Let's look at this FXE angle here, right? This angle here, the parallel line here. So this angle, this is actually parallel to this, and this one XE is parallel to WC. So we have the angle formed by two parallel lines are equal to each other. In other words, FXE, XE, okay, it's going to equal BHC. We have parallelogram here because the middle line, right? So let's mark the parallelogram here. So we have the A, F, D, E. This is actually parallel, right? This highlighted one here. So BHC here, this is BHC, right? is equal to this one, right? Equal to this one. And BHC, we know that is 180 degree minus angle A. And angle A, of course, the BAC would equal this angle, right? This is parallelogram, right? So this one equal angle EDF. Okay, and equal 180 degree minus this. So if we combine the two, what do we have? We have FXE. Oh wait, the pen somehow is very sluggish here. FXE gonna equal 180 degrees, right? Minus EDF. Okay, what are the two angles? Let's mark it, right? So here, the FXE is this one, right? FXE is this one, and EDF is this one. So we're saying that they add up to 180 degrees. So let's look at this. Too many highlights here, right? So let's redraw this diagram. Let's redraw the original diagram here. All right. So for the 4 points we are interested in, which is D, E, X, and okay, so we have proven that the opposing angle add up to 180 degrees, right? So FXE, this one, is equal 180 degree minus EDF. So earlier we know that the 4 points D, E, F, X are on the same circle. So which means X belongs to the same circle. Similarly, YZ, which is the same definition here, is on the same circle. So we have proven the remaining 3 points, which is X, Y, Z, are also on the same circle. X, Y, Z. So we have 9 points here. They're all on the same circle. This is called 9-point circle. There are other interesting properties of this circle, and in fact, there is a property that the radius of this blue circle versus the circumcircle of BAC, the original triangle ABC, and the radius actually is half of the circumcircle of ABC here, right? So that's we can talk about it in another video. And today is my first effort to run live. I don't know what the experience looks like. If I should use a different software, we're gonna see what we can improve on top of the current setup. All right. So thanks for your time. I'm gonna end the